chat. Cool. 931 minimum flowing path sum. Given a square array of integers a, we want the minimum sum of a flowing path through a. A flowing path starts at any element in the first row. Choose one element from each row. The next row's choice must be a column that's different from the previous row by at most one. Okay. So, what does this mean? Oh, wow. This is, I guess, just really exhaustive. All the flowing paths, but portrayed in a weird way. Yeah. Do we get to start at anyway? Okay. Yeah, I mean, I think this is a very straightforward dynamic programming problem. Yeah, so I think I'm just going to jump right into it. I think so. The dynamic or the recursion you can think of, the subproblems that you're trying to figure out is that for a given cell xy, what is the minimum of some the minimal flowing path through that point, and that's something that I could do with dynamic programming. What's the max size? 100. Okay. We need a new keyboard. We're looking for minimal, so and each element on the list could be 100. So let's just say. Say million. Okay. Yeah. We just go through it actually. So this time I am smart enough. Well, maybe not smart enough, but learning from my mistake that this is an array of sizes for some reason. I guess it's just a generic thing, but anyway, okay. Okay. I guess we could set the first row, which is okay. And now we can start from 1. It's 2. I mean, you could probably clean this up a little bit, but I'm just a little bit lazy, so not lazy, but just gonna do it the dumb way. Right? Something's a little off. Oh. If this is, you want the minimum? Okay. Okay. I guess I should keep track of the minimum. Was it? Oh. Okay, cool. Should be okay, maybe, hopefully. Now. Oh, of course, J is not. Oops. Good catch, compiler. Thanks. Cool. Oh, I guess they only gave you one test case, so alright, whatever. YOLO, as the kids would say. Oh, no. Huh. I mean, that's clearly true, but why did I give them a 1? I have a type. Is this not popping off? Why not? Okay. Huh. Why is that the case? Did I take max by accident? Maybe I did the sign well. Oh, it shouldn't be, but definitely seems like it's trying to do the max though, but this is bigger than this. I guess it doesn't print this way. What did I get wrong? Is this less than or equal to? No, that doesn't make sense. So I is the row. Just version. Yeah, I didn't think that would change anything, but oh. Maybe we'll commit out of bounds there. Oh, it doesn't. Huh, that's odd. I mean, Guess we probably factor in some infinity somewhere, but oh man. Oops. That's what you get for mixing I's and J's. I guess I should have been more clear in this case. Okay, let's try again. Yeah. Oops. Cool. Yeah, I mean, whoops, I set the base case on the wrong index. But yeah, I mean, I think this is a very straightforward dynamic programming problem. It's just you look at the last couple of rows, and actually, so if we were talking about analysis on this problem, so this is n square, where n is just, or n times m, depending on how you want to phrase it, where n is the number of rows and the m is the number of columns or something like that, which is, let's say n square. And space is also clearly n squared the way I invented it, but actually if you kind of notice, you only need to look at the last array index for dynamic programming, so you can actually get away with all of n space, and maybe if I have time then I would point it out or recode parts of this to reflect that. I think this is a very standard algorithm class textbook problem type thing, so so I think it is probably a little bit on the easy side for an interview, but yeah, and there's no complication or anything that will test it. So it's either, so the problem ends up being, hey, do you know this problem from dynamic programming or not? And don't, if and if you know dynamic programming, you can probably figure it out anyway. So it's not necessarily that you have to see this problem before, but it's just very I don't know, very single dimension, if you mind the ironic pun. But yeah, so I would probably try to I mean, maybe this is part of, like, I would use the core of this problem as part of a bigger problem, as an interview question, to kind of gauge where the interviewee is at, especially if he or she is having trouble with parts of the overall problem. Then we could give hints and figure it out, different parts. And here it seems like for this problem, if you didn't know the answer, you're not going to really have a way to go through it. Maybe you have some like greedy E algorithm, which obviously it's going to be wrong for some case, and you could kind of talk through it. But in general, it's going to be suboptimal and just not something that I don't know. It's a little just too easy and hit or miss, and you really, there's nothing like you're not going to know how they structure the code. I mean, maybe if I look at the code I have here, maybe, yeah, okay, you could put the initialization in a different function or base case in a different function, but that's just like really low stakes. So I don't know if I would count that.